Good morning, students. Today I am going to explain Born-Haber cycle. This is very important for board exam. I will explain that one and some difficulties you may felt about that Born-Haber cycle. I will explain everything. First, I will introduce what are the things that we have to know before entering into the cycle. Mainly, we have to know about the dissociation lattice enthalpy and formation in lattice enthalpy. Usually, lattice enthalpy, we are having two kind of lattice enthalpy. One lattice enthalpy will be formation lattice enthalpy or lattice formation enthalpy, whatever may be. Lattice formation enthalpy. Lattice will be formed here. So lattice formation enthalpy. Lattice is nothing but the ionic solid. Lattice formation enthalpy, and this will be called as lattice. Another kind will be called as lattice dissociation enthalpy. Two kind of enthalpy will be there. Normally in our AS level board exam, AS level, A level, IBHL, and then IB Chem, in every case, international standard, they will use that formation lattice enthalpy. NEET exam, JEE exam, CBSE, board exam, state board exam. For every case that is in that standard, they will use that lattice dissociation enthalpy. That's why when you are checking through the internet, you would felt some there will be a lot of difficulties when while understanding that Born-Haber cycle. I will explain that. I will clear everything here. So lattice enthalpy is having two kind. One is lattice formation enthalpy, one is lattice dissociation enthalpy. So in AS level, A level for board exam, I will give you the definition of lattice formation enthalpy or lattice enthalpy for AS level, A level definition. So first of all, what is the definition for lattice enthalpy? Here, lattice formation enthalpy. The name itself is saying the lattice is going to be formed. So energy released. Why the energy has been released? Whenever you want to break something, you have to give some energy, but if you want to form something, the energy will be absorbed. So when the reaction involved in the formation, then there will be a energy release, and when there is a dissociation, that is the dissociation or breaking is there in the reaction, then there should be energy absorbed. So energy released means that will be called as exothermic. So here, during the formation, energy will be released. Energy or heat energy or enthalpy, everything will be same. The energy released during the formation of, during 1 mole of ionic solid. Ionic solid formed from the gaseous ions. You should be very careful. Here 1 mole should be formed and the gaseous state. The ion should be in the gaseous state. For example, if I am taking NaCl ionic solid, 1 mole of Na plus and 1 mole of Cl minus will give 1 mole of NaCl solid, and you have to take both the one in the gaseous state. So this, for this reaction, there will be a releasing of heat energy. Then we can indicate that one as delta H naught. If you are taking 1 mole and if you are maintaining 298 Kelvin temperature, and if you are maintaining the pressure 1 atmosphere, then you can use this one, delta H naught, standard lattice formation enthalpy, and that will be always exothermic. This is the definition. In AS level, A level, you have to use this definition. In CBSE level, the definition will be somewhat differing. That is the energy absorbed. Here, the energy. Students, please pause this video here and try to give the dissociation enthalpy definition as your own way, and then check whether your definition is right or wrong. Pause this video here. Okay, now energy absorbed during the dissociation of, during the dissociation of 1 mole ionic crystal, dissociation of 1 mole ionic crystal or ionic solid into gaseous ions. So NaCl will give Na plus and Cl minus, and both should be in gaseous form. For this reaction, you can indicate the energy change as delta H, lattice dissociation enthalpy. It will be positive. Usually, this definition, be clear, this definition will be used for board exam for CBSE level. Students, actually, we are following the CBSE standard for NEET JEE Bitshed exam. So you have to follow this lattice enthalpy definition. But in the board exam, you should not write for AS level, A level, you should not write this definition. But if you are learning the board exam in AS level, A level, and if you want to try to, that is, if you want to try to achieve in NEET and JEE, then you should know about that lattice dissociation concept also. That's why I'm introducing both. I will explain the Born-Haber cycle. In the Born-Haber cycle, I will explain both the case. That is a CBSE level as well as AS level, A level. Both the case I will explain. Don't worry. It will be very, very easy. If you have understood well, then the concept clarity will be somewhat extraordinary within you. That's why I'm explaining both in one video. Ready for that? Okay, first of all, in Born-Haber cycle, I'm going to write the energy graph. Students, in when you are checking through the internet, the images, there are lots and lots of error. Please don't refer that. Please refer my Born-Haber cycle. With confidence, I'm saying that one. Whenever you are checking through the internet, each one will have a different kind of lattice energy. Some they won't explain about that why they are using that lattice energy kind, and then there will be a error in the energy graph also. So I will give the exact graph for you. You can refer this for both CBSE as well as AS level. I will explain both the one. So energy, I'm going to involve that energy. That is, I'm going to take that energy or energy or enthalpy in the y-axis. So first of all, I'm going to form that sodium chloride. For that, I'm going to take that sodium in a solid form, because in our earth, the elemental state of sodium will be monoatomic state, and it will be in a solid form, and chlorine will be gaseous state. But for NaCl formation, I need only one chlorine atom. That's why I'm taking half mole of Cl2 in gaseous state. So both are in the same energy because I'm taking at room temperature. So both will be in the same energy. But I'm going to convert only sodium into gaseous state. Sodium into gaseous state. So when I am changing the sodium into solid, from solid to gaseous state, the process will be called as sublimation. So sublimation will be indicated like this: delta H naught sublimation enthalpy. I am just raising its energy, and I'm breaking that solid into gaseous ion. Sometimes they may say that atomization enthalpy also, students. In some book, that is AS level itself, they will in some book they are saying that as a sublimation enthalpy or atomization enthalpy. Both are same, students, because we are changing that sodium solid. That sodium solid will be in the metallic form. We are converting that into simple ions, sorry, simple atoms. That's why we can say that as a delta H atomization, AT. They would refer that one as a delta H naught AT. You can refer like this also. This is for AS level students. And then here Cl2 we are not changing, in till now we are not changing that one because already it is in the gaseous state. And then we have to convert that into gaseous ions because we are going to find out the lattice energy. That's why I'm trying to find out that gaseous ion. So I have to remove, if I want to make the sodium into ion, I have to remove one electron. That's why I'm just removing that one electron. The removing of electron from the outer shell from one mole of gaseous atom will be called as ionization enthalpy. So we can refer like this: delta H naught ionization enthalpy. So here I have converted that sodium into gaseous ions, but I am not converting that chlorine into ion. So first of all, I don't need the process of converting that into gaseous state because it is already in the gaseous state, but I need the atom. So what I am going to do, first I am going to convert that into atom. So I'm going to just break that into 2Cl2. That is one Cl2 into 2Cl atom, but it is half Cl. That's why I'm just converting that into chlorine, 1 mole of chlorine atom. So 1 mole of chlorine atom I'm getting, but I'm just dissociating. That is, I'm just breaking the bond of half mole of Cl2. That's why I have to use that delta H naught bond energy for, or bond enthalpy for. Bond enthalpy means what is that? Energy required to break the bond. That is called bond enthalpy or bond energy. So I am just breaking that chlorine into chlorine atom, chlorine molecule into chlorine atom, but I am just breaking half mole only. to get the 1 mole of gaseous atom. That's why I'm taking, that is 1 mole means we can use the delta H naught. That is standard condition. We have to use always 1 mole. But here I am taking only half mole. That's why I have taken that half of delta H naught bond enthalpy. And then I am converting that into ion. So how can I convert that into ion? The released electron will be there. So when you are adding that electron, then you will get the Cl minus ion. Now you are having Na plus ion and Cl minus ion in the gaseous state. So look at this. This will be called as delta H naught. We are adding one electron. That is called electron gain. So this is called electron gain enthalpy. Now everything is over. So Na plus gaseous state, Cl minus gaseous state formed. Then finally I will get the crystal formation. That is, I will get the crystal NaCl. So usually that NaCl will be in the solid form, right? So you should not mention that in a higher energy. So I am just taking that in a lower energy. So in that case, NaCl ionic solid will be formed. Look at this. This will form. Finally, here Na, that is a sodium solid and the chlorine gaseous state. Chlorine molecule in the gaseous state forms NaCl. Here, one interesting process is there. Directly we can go to this one. Directly, if we are moving from here to here, that will be called as delta H naught formation formation. It's just a formation. It's not a lattice formation. It's a formation. Lattice formation is from the constituent ions, but the formation is for the elemental state of atoms. 1 mole of element, 1 mole of molecule should be formed from the elemental state. That will be called as formation. So directly if you are entering into NaCl solid state, that is called formation enthalpy. But in this case, look at this. I am just going to explain the AS level and AL level Born-Haber cycle. That's why you have to go for it. Delta H naught lattice formation enthalpy. Look at this. The energy of the ions will be in that place. But here, now the energy is decreased. So that decreasing energy will be released as a formation lattice enthalpy. That is why we are having negative. So delta H will be negative in this case. That is for Born-Haber cycle, delta H will be negative. Students, you can use this Born-Haber cycle when they are asking in the board exam. Please don't refer anything. It will confuse you. When you are checking through the internet, they will confuse both AS level board Born-Haber cycle as well as A level. But in that case itself, that even they are using that one kind of explanation, that also in that case also they made so many errors. That's why please don't use that. You can use this one itself. Everything I have explained here. That's why now why we need the Born-Haber cycle. We want to determine the lattice enthalpy. That's the purpose of Born-Haber cycle. So what I'm going to do, I'm going to apply the Hess law. What is Hess law? When you are going A to D directly, and then when you are using some another path like this, both the path will have a same enthalpy change. For example, if it is a delta H, if it is a delta H1, delta H2, delta H3, then delta H will be equal to delta H1 plus delta H2 plus delta H3. This is called Hess law. We are going to apply the same thing for Born-Haber cycle. So how we can, this is a direct process. Look at this. This is a direct process. And these are all indirect process. So I'm going to use the direct process and indirect process, because I know that according to Hess law, both process involve same energy. So delta H formation. What is that formation? NaCl, 1 mole of NaCl formed from the elemental state, not from ions. If it is formed from ions, we can say that as a lattice formation. So delta H formation will be equal to delta H naught sublimation or atomization. I am using atomization because it is used for AS level and A level, and then delta H naught ionization enthalpy, and then half mole of delta H naught bond enthalpy of chlorine, and then delta H naught electron gain enthalpy. And then finally I am having the lattice enthalpy, delta H naught lattice enthalpy. So if you are calculating everything here, please don't refer that, don't mention that as a negative, because you may confuse that whether we have to substitute the negative lattice enthalpy positive. No, it's not like that. whatever the energy change, we have to just add according to Hess law. So if you are having the formation value, atomization value for sodium atom, and ionization enthalpy for sodium atom, and bond enthalpy of chlorine molecule, and then electron gain enthalpy of chlorine, then you can easily find out the delta H lattice energy. So the delta H naught lattice enthalpy, if you want to find out, then delta H naught formation enthalpy minus delta H naught atomization minus delta H naught ionization enthalpy minus half delta H naught bond enthalpy, and then minus delta H naught electron gain enthalpy. This is the way to find out the lattice enthalpy according to AS level and A level. I will explain for CBSE and NEET competitive also. That will be very easy, students. Don't think like that. That will be somewhat difficult, ma'am. How can I learn that one? Please don't think like that. Same thing will be there. I will explain with the same kind. So I'm going to take that same Born-Haber cycle, but now I'm going to explain for the CBSE case, and then our NEET and JE case also. Look at this. Here everything will be same. Everything will be same. No more change. Only one change, that lattice dissociation enthalpy we are going to use, right? So we know that when 1 mole of NaCl is dissociated into constituent atoms. Look at this properly. I am just taking that 1 mole of NaCl is converted into gaseous ions. I will just take that as a lattice dissociation enthalpy. So I'm just going to take this one as a lattice energy for CBSE, right? For CBSE, this will be the lattice energy. The reverse process is called lattice energy. Then how can I call that forward process? Because the Hess law, I can apply only the forward process, right? That is the energy directly we can go here, and indirectly we can go like this. So I don't need the reverse process energy. I need the forward process energy. That's why you can mention the forward process energy as delta H naught minus delta H lattice dissociation. Remember that in the, if you want to give in terms of dissociation, then this process will be indicated as delta H naught lattice dissociation. Now we don't need this one. I'm just taking that out. In AS level, AB level, A level, we will use that delta H naught lattice formation. That's why I have taken the directly plus, but we will use the dissociation only for CBSE level. That's why this is actually the formation. That's why for dissociation, I have just taken the negative. Then how can I change this one? Here, this is the negative, right? Now only we have to use the symbol negative. Now the delta H lattice enthalpy will be negative, delta H formation, everything will be plus. You can check that in your CBSE book. Thank you, students.